And the step 7 is, plot different additional point, no? Additional plot, additional point. Right. I know say I'm recording or not. Let me check it. Yes. Some good student doing the recording. Cool. Okay, the symmetry is pretty easy, but in this case we have no symmetry, and the reason is clear. Look, let me come back to the original expression. That one. Okay, the name is G. So you make a symmetry, a reflection, sorry, in order to verification. Okay, guys, after you talking about the WhatsApp group, well, we have, remember, when you change x for negative x, the exponent even stay the same. However, the exponent of no change. And this can have no x stay the same. And the bottom is stay x squared plus 1. When you compare this and the original against this, you see, wow, it's not equal. So it's no even, nor odd. Therefore, is neither. There is no frustrate for this, because the only bad thing is that you don't take advantage of the symmetry because there are no symmetry. Because now you obviously need to take the plot, the positive part and the negative part completely independent. There are no connection. But it's okay. Now, in order to plot some point, I decide, look at the graph. I did the graph here. I make a screenshot in Desmos to avoid, okay, I switch into Desmo. Okay, so now in this example, you see, let me select quickly. You see different point. This is the X and a Z. This is the Y and a Z. Okay, we computed before. And the red point is the typical. I select, for example, this is -1, -2, -3. I select G and -3 is 2.2. You plug it in the formula. That's it. And +1 is -3, and +5 is 1.15 positive. Okay, now the important, super important crossing point is this. It's a crossing point. I remember it was -7/3, 2. Okay, this is a fraction, but in decimal is -2.2. And also, I remember that this rational function have only one horizontal asymptote at y equal, I don't remember, 2. There you go, here. And we have no vertical. The vertical doesn't exist. Okay, cool. This is the graph. End the story, no more. Any question, guys? Do you understand very well? Okay, yes or no? Say something.
Something.
Yes, something.
Yes.
I like this answer. Okay, now let's move on to the next topic inside the chapter 1. Okay, is the solution of the polynomial and rational inequality. So the topic is, let me make a zoom. Polynomial, polynomial and rational inequality. Actually, it is the non-linear inequality. So we cannot solving in the traditional method or approach, we solve the linear in the college. So now we see this. The idea is super straightforward. It's easy. For example, let me start for the polynomial first. A couple of problems of polynomial, and after we go back to the rational. Polynomial. We have, suppose this example. Example number 1. Suppose that we have x cubed plus 2 x squared minus 3x greater than 0. What happened with the soil? Guy, I saying any lecture, I saying new link. No, it's not the same link. You open the email. You see the link I sent today, and you click in the link. I suppose that everyone is doing well. Okay. Well, to say now, what is the procedure for solving this? Okay. You have important. You have the left-hand side, okay, so in that case, a polynomial, and the right-hand side, in this case, 0. I highly recommend when you solving this kind of inequality, it's important to understand, and you understand, not exactly now, but in a few minutes you understand the reason. Okay, you put in the right-hand side 0, so right-hand side always to start must be 0. The reason maybe it's not clear now, but I want to prove this. Okay, that's what should I do? Well, you factorization. You factorization the polynomial, okay? In this case, it's easy, not necessarily scientific division. No. Very common factor is x, factor of x. You have x squared plus 2x minus 3 greater than 0. And that's a trinomial factorization. Trinomial factorization is easy. You break it down into binomial. It's x, and the combination can open the door. I suppose it's 3 and 1, because 3 times 1 is 3, and 3 minus 1 is 2. And the sign is different, positive 3 and negative 1. Okay, ready. And you now have the new view of the inequality because you express the left-hand side in factorial form. Okay, now we start. To solving this, always you temporary, you convert the inequality in equation. So you temporary, you replace this greater than sign to equal sign, and you solve this equation. Wow, this is nothing for us. A solution is 0, solution is negative 3, and solution is positive. And this guy is important in the solution. It's not the solution, but it's important to determine the solution, and this is called critical value. After that, we use this critical value to say this is the part. So the solution of the inequality, this kind of inequality, is one part algebraically and one part graphically. I want to see both in the solution when you send me by email. I don't know what happened, guys. I sent for everyone, or at least the email. Okay, now this is the line that represents orient. Infinity positive, infinity negative. And by the way, 0 in the middle. And you plot this one. You plot 0, well, I did that. You plot -3, -1, -2, -3, and +1. Okay, cool. Now, why not? You are doing partitions of the number line. So we're using the critical value to make. Oh. Let me try to explain my lecture. Now, using the critical value, you make partition. In this case, we have 3 critical values. We have 3 partitions, but this generate 4 intervals. So now you pick arbitrary, total arbitrary, guys. Testing point. This is the new idea. Testing point. Testing point inside each interval. For example, totally different. See, another student are doing differently, no problem. The answer doesn't change. For example, we have 4 intervals. This is one interval. This is another interval. This is another interval, and this is another interval. Actually, it's 4 intervals. And you pick totally arbitrary value inside. You pick -4, maybe it's good, can represent this interval. You pick -1, maybe it's good. Suppose another student pick -2, it's okay. You pick 1/2 positive. And you pick 2, 3, 4, 5. I pick 2. And this is the testing point. And this testing point, you can, if you want, plugging in inside this inequality and verification, see it's true or not. One fantastic way, in my opinion, I respect any procedure, any methodology. Okay, some students want to using, and your answer is correct. So I hear some teacher and some tutor explain that you plug in -4, -1, +1/2, and 2 into the original inequality. Okay, it's perfect. However, I prefer more elegant way. Is you create a table. In the table, I put one first column in which I listing the testing point, que es -4, -1, half, +1/2, and 2. And you evaluate not in the totally, sino you evaluate factor by factor. You evaluate in X, que es easier, is not necessarily calculated. You can do by hand, in X +3, and in X -1. Okay, so now we have one extra column que es the total. I call it total. Doesn't matter, then it's not important. So now this is a crucial moment in which you plugging in that testing point one by one into the expression. It's obvious that when you plug in X is negative. It's -4 actually, but I don't care the value. I care only the signs. This is also negative because it's -4 + 3. I suppose you see that, right? And -1, they put negative. -4 and -1 is -5. 3 negative. And 3 negative multiplication is obvious is negative. And this is the important information. That is the reason they enclose in the circle. This is partial, but this is total. And -1 is negative. And -1 is positive. Because -1 + 3 is 2, positive 2. And -1 - 1 is -2 is negative. So you have 2 negative is positive. Entonces the control of the sign is determining by the amount of negative we have in the factor. So you have 3 negative, it's negative. So you have 2 negative, positive. So you have 4 negative, it's positive. So you have 1 negative, it's obviously negative. So the control of the sign is given by the number of negative. And the positive is no important, not too much important. Okay, so now let's continue to fill out the table. No, just now it's plus because 1/2 is positive. No? 1/2 plus 3 is positive, and 1/2 minus 1 is negative. 1/2 is negative. We have 1 negative is negative. And 2, 2 is positive because 2 plus 3 is 5, and 2 minus 1 is positive 1, is positive, 3 positive is over the positive. Guys, do you understand so far this idea or no? Yes or no?
I mean, it's just a line where it says negative infinity to positive infinity, and then after that.
Let me try to explain. Look, let me try to do at least the first row 1, that one. The testing point I want to analyze is -4. And -4 you plug in one by one in this expression, in this expression, in this expression. Let's do it. When you multiply, you plug in -4 and x is -4. That is the reason that this negative I write here. I don't care the value. The value is totally irrelevant. When you plug in -4 and this expression is -4 plus 3 is -1. Entonces this negative I write again here. Now, and the last one, last column is -4 plus -1. Because you replace in your mind this x for -4 and -4. And this negative I write here. And 3 negative is obvious is negative because negative times negative times negative is negative, right? Negative value. I don't care the value because I put it enclosed in the circle to indicate that this is my final answer, no? This idea is clear or no? Miss, tell me.
Yes.
Okay, no, the lady can ask me a question. No?
Wait,
Where
so
did you get the half from?
Say again?
Where did you get the half from?
The half was totally arbitrary testing point in between 0 and 1. I pick 1/2, I pick 1/3, I pick 1/5, I pick 3/4. It's a totally, you have, at the beginning you have 4 intervals. 1, 2, 3, and 4. If I select totally arbitrary testing point inside each interval. Do you follow me?
Professor.
Uh-huh.
So you would choose one random point from each section?
Yes. This working like one country. We have the all real number line, it's a word, and you split in different countries. United States, Mexico, Canadian, Guatemala, whatever. And you pick one citizen inside each interval. And you testing. You are American? No. Yes. You are Mexican? Yes. No. This is the idea, right? Clear or no? A ver.
Yes, I get it.
The right point is between -4 and +2.
Bueno, actually, remember, the critical value are 0, -3, and +1. And this guy determines the partition. I put a dotted line to indicate the partition. This partition is 3, generate 4 intervals. And this 4 intervals generate 4 testing points. Entonces, less than -3, I pick -4. Suppose que another student pick -5 or -6, it's okay. It's the same answer. It's the same answer. And between -3 and 0, I pick -1. And between 0 and 1, I pick 1/2. After 1, greater than 1, I pick 2 or 3 or 4, but I pick 2 to create my table. More clear now? More clear now? I don't finish. We almost finished. Everyone follow me so far?
Yes.
Okay, cool. Now, crucial moment. Because I come back. to my inequality. Look, my inequality is this inequality. Here I can see, wow, greater than 0. And to be greater than 0 is equivalent to make positive. So the true statement in the table is the positive. So this is true. And it's true. So basically, the testing point que pass the test is -1 and +2. -4, no. And 1/2, no, no good. Now, entonces now I know what is my answer of the inequality. I highlight. Let me try to use another color. Maybe green is good. Green, dark green. Yeah. Also, I highlight this interval. Look, because the testing point -1, it's good, pass the test. And 2 also, que es this interval. Remember, you highlight from the critical value because 2 was arbitrary testing point at the beginning, yeah? Okay, so what is my final answer? Okay, keep in mind, it's important to denote, express it clear the interval. I don't know if the interval is open or closed. In this case, it's open because the endpoint -3 and 0 don't belong to the solution. And the reason is because my inequality have no equal sign here. So no equal sign, that means that my inequality is a strict inequality, no equation. Now the endpoint is -3 and 0 don't belong to the solution, and 1 don't belong to the solution. So what is my final answer? Final answer. The final answer is, well, is parentheses 3 -3, 0. Union 1, infinity. Because the solution have 2 pieces separately. Therefore, you need to express it both, no? Entonces, this is one piece, so that piece corresponds to this piece, and this piece corresponds with that piece. And you connecting both pieces by the mathematical symbol union, que is look like capital U, no? Actually, no capital U, it's a specific symbol que indicate union in between both intervals, like that. Super cool or super confused? Come on, speak.
I'm confused.
What part?
How you concluded that -3 and 1 is the final answer?
Good question. Because, mister, suppose that our inequality, another problem, no, this problem, have equal sign. This changed completely the meaning of the problem because now we included an equal sign. So equal sign that was my friend to make a partition now participate in the solution. So now this is good, and this is good. So you put the bracket, and here bracket. Remember, parentheses and the inequality indicate also, I don't know if you remember this is the intermediate algebra, include the endpoint. When they include the endpoint, you put a bracket, but you do not include the endpoint parentheses. The reason que no include is because our inequality in this example number 1 is just a strict inequality and no equation. But always is like that? No. You see now example 2, example 3, example 4, and so on. I try to add in. Okay, I try to add in. Jenny say no risk. What happened? Okay, entonces clear or confusing? One more example, no? To clarify more. Yes or no? Yes or no?
No, it's clear.
Example 2. Example 2 bring me new situation. Pay attention. Suppose x to the 4th power greater than or equal 4x squared. Totally different. Entonces, what should I do? Step number 0 to start. Well, remember the thing I explained. The right-hand side, guys, always 100% must be 0. Why? Because remember, when you create the table, you put positive or negative. So positive indicate us. Suppose 0 is important because 0 is the level, the comparison level of the sea, for example. Si you have positive number is above the sea level, and si es negative, it's only the water. No? So it's important in order to solve any inequality, now polynomial or rational, you manipulate our inequality in order to create a right-hand side must be 0. Mandatory this idea. Okay. Now we start. Start factorization. In this case, the greater common factor. You using the classical technique of factorization. Greater common factor is x squared. You factor out x squared is x squared minus 1. Well, you take online the class. You take the class online. Shouldn't. You take I teaching in person this class. But you take online. This is one possibility. Okay, guys, this is a free country. You need to analyze. This is important moment. See, this is for you or no. Okay, this is not for everyone. The class online is not for everyone. The class online have advantage and disadvantage. But I don't want to speak about this because my goal is pre-calculus. So I need to explain this, okay? So you make a decision, you're adult people, and you decide if it's good or not. You drop the class with anticipation and don't affect anything, you pay money. Okay, now you have factor complete.
I'm sorry, Professor, excuse me.
Okay,
since I was reading the chat and it looks like some students have been trying to log in to the meeting. And it's not letting them because it says that the class is too full at the moment. That's what they're talking about.
No, some students email me, Professor, you can include it. No, I am full. No more students. Okay, I am not the only teacher in Miami-Dade College. Okay, I know I am famous, but no. Take another teacher waiting for me in the next semester. Okay. Entonces we can continue or no?
Yes, we can.
Yeah, cool. Entonces now I continue factor completely, of course. Here I can see, wow, this is the differences of the square. And you factorization like a two binomial, xx22 plus or minus. Okay, so when you finish the factorization, you enclose this new inequality in the box. Okay, by the way, it's equivalent 100% to the original ugly, can nobody understand. However, this is easier to manipulate in the way that you are doing before. Look, remember, next step is try to find the critical value. To find the critical value, you take the original inequality, but you enforce it equals 0. Entonces it's so clear. Wow, x equals 0. By the way, multiplicity 2, actually this is like a 0,0, so 0 2 times. Remember, this is a polynomial, guys, degree 4. And polynomial degree 4, we have 4 zeros, 4 solutions. But the multiplicity count, so it's 0,0, negative 2, multiplicity 1, of course, 1 time, and positive 2, multiplicity 1 time. And this is the collection of our critical value, CB. And we're using this to make a partition. It's always the same. I want to see in the test, factorization, critical value, graphic part using the partitions, Infinity positive, infinity negative. Again, 0 is one partition. Positive 2 and negative 2. One more time, we have 3 partitions, 4 interval. And you pick arbitrary testing. Maybe negative 3, maybe negative 1, maybe positive 1, and maybe 3. See, another student select different value inside the interval. It's the same behavior. Doesn't affect. Of course, you are smart and using nice value. No decimal or fraction, crazy. No. See, we need, of course, yes, but no. I select nice value. And now create the table. Be careful because in the table we have some new, totally different. I listing vertically the testing point. -1, +1, and +3. Okay, and remember, in the column of the table, I put a difference factors of my problem is x squared, x plus 2, and x minus 2. I copy that. Okay, it's x squared, okay, cool. X plus 2, and x minus 2. And don't forget, important, the total column, because this is the conclusion. This is the conclusion. Okay. So when you plug in negative 3x squared, so negative 3x squared and 9, positive 9, that's positive. And you see, wow. So always this column is positive, because regardless if the value is positive or negative, you know when you square any number, negative or positive, the answer is positive. For all hams, I try to explain that the control of the inequality is given by the negative sign. So the important, guys, is the negative. The positive is totally irrelevant. Not 100%, but it's less important. Entonces now, it's the first time that you see that situation. This column, you can delete. How do you know? I want to explain in detail. This is the first example of the delete factor. But one first approach to understand delete is any even exponent you delete. So now, actually, my inequality, see, I know this at the beginning, I can write my inequality like that. I guarantee you 100%. Okay, this inequality, this one, and this inequality have the same solution. So we can delete this guy. The reason is not totally clear now. I understand. I want to explain in the next example more clear when you delete or when you partial delete, because sometimes you need to partial delete. In this case, no. In this case, no partial. It's totally delete. Totally delete. In this scenario. The reason is not clear, but I want to explain in a few seconds. In a few minutes. Okay, let's continue, guys. The rest is mechanical. You plug it in here as negative, you plug it in here as negative, and 2 negative is positive. Now negative 1 is positive, and negative 1 is negative, so 1 negative is negative, and 1 is positive, and 1 is negative, so it's negative again, and 3 plus 2 is 5, and 3 minus 2 is 1, that's positive. Again, coincidence in this example, okay, we are talking about greater than or equal to 0, que es sinónimo to C positive. Not always happen, you see another example, que es less than, entonces the negative. So in this case, the positive guy is the truth. But not always the positive is the truth. See, our inequality have less than at the beginning, the truth is the negative. But no, I don't want to complicate more this so far. You see one example, I solve one example, I solve another example. The truth is this and this. Okay? Now I highlight with the red color, I highlight the solution of our inequality bar. It's this bar. Remember, -3 was true, and +3 was true. And what about the endpoint? It's included. Yes, it's included, Professor, because our inequality is the composition, one inequality greater than an equal sign. This and this symbol is equivalent to say this or this. Therefore, the solution of the equation, that by the way is a critical value, belong to the solution, and you put the bracket here and a bracket here, no parentheses. And also, what about 0, Professor? 0 belong? Yes, 0 belong is totally isolated point in the middle. Okay, so what is my final answer? I finished. What is my final answer then? Well, my final answer is from negative infinity, I walking from left to right, comma -2, bracket, or important is symbol, union, walking from left to right, 0, but 0 is no interval, 0 is just isolated point in the middle. So you put like a using curly bracket, exactly the same we are doing solution for the equation. The equation in the solving is 1, 2, 3. We're using this notation when it's no intervals, you know, it's a fixed point. Now, finally, union, because we have actually 1, 2, 3 pieces, bracket, 2, comma infinity. Final answer. Any question? Any question? What part is confusing? Clear? How
can we put the 0 for the last example?
Say again?
For the last example. Why didn't we include 0?
Well, remember the idea behind the solution is determine if it's positive or negative. So to be right-hand side 0 is super useful because it's a level to comparison. So below 0 is positive, and above 0, sorry, is positive, and below 0 is negative. That's the level of comparison. No one number, no 2, no 3, no, it's 0, important 0. I don't know if it's your question, mister. Mister?
Yes. So because the 0 is in between, we include it for this example.
Yeah. So suppose que in the example, like in this example too, the inequality que is given is totally disorganized, crazy, no right-hand side 0. You must be 0. So you bring this guy to the right, to the left, like a minus, and now you have right-hand side 0. Good.
Also.
Yes.
Also.
You put the brackets because you included the x squared.
Absolutely. Okay. So this sign changed completely the meaning. Look, this equal. So es bracket. Y es no, entonces es paréntesis. Okay, so let me try, because it's a little bit complicated to explain some special cases that we frequently found when you solving this kind of inequality. So in this special, I want to explain, I'll try to explain, I don't know if I can or no, the difference when there's partial delete or totally delete, okay? Suppose this example, x minus 5, parentheses, x minus 4 squared, greater than or equal to 0. And the teacher, I remember explained that when the sum factor have even exponent, even exponent, you can delete. And the reason is clear, is because it's always positive, no? So this binomial is always positive. Okay, so now immediately when you see that, you convert this, may be complicated or no, inequality in one super easy like that. And you solve this in 5 seconds because this is x greater than or equal 5. And you express it always, guys, the answer in interval notation, the bracket 5, comma infinity. Do you understand very well the idea behind this? In order to simplification our expression, you take the factor gets raised to the even exponent, not necessarily 2, maybe 4, maybe 6, because it's always possible, right? Clear or no? Clear or no?
Clear.
Excellent. We have another scenario. Suppose similar, but now I change a little bit. X minus 4 squared again, but greater than 0. You see, well, no, it's the same. No, it's not the same. Why no, it's not the same? Because so you delete totally the factor x minus 4, you have a contradiction. Because you get contradiction. Let me try. For example, well, actually, the idea is you copy x minus 5 greater than or equal 4. Okay, it's 5, 6, 7. But you delete totally this. No good. Because what happened in 4? So you put an x no 4. Hey, please. Putting off the microphone. What happened today, guys? Off microphone. Why? Let me try to explain why. What is this contradiction? Suppose what happened in 4? Well, what happened in 4? In 4, you plug it in here. 4 minus 5. 4 minus 4 squared greater than or equal to 0. 4 minus 5 is negative 1. And 4 minus 4 is 0. And 0 squared is 0. And 0 times anything is 0. And 0 no is greater than 0. Therefore, this is a typical scenario in which you partially delete, in this case, totally delete in this case, no. In this case, partial delete. How you partial delete? When you copy the factor that contains an odd exponent like this, for example, the 1, it's a copy, but you exclude the factor can contain even exponent, but you enforcing that restriction, no 4. Okay, entonces es easy, because when it's equal sign, you totally delete. When there's no equal, you partially. And you consider it like a one restriction. You put and, this is like a compound inequality, no? One inequality and another inequality gets a whole here. So what is the solution of this? Well, the solution, you solving that. I did that before. The answer of that part is bracket 5, comma infinity, no? And this is no 4. What is the representation of this? Well, the representation is easy, look. And remember, any compound inequality is cool doing graphical, because it's complicated doing without graphic. Okay, this is 0. This is 1, 2, 3, 4, and this is 5. Well, in this case, not necessarily this, because this interval is from 5 to infinity. This interval is this. And the whole case in 4 lie out the interval. Entonces now you don't care this whole, because it's out. So the intersection this and this together is obvious que es this. So in this case, they are perfect coincidence with this answer, but not always. Let me show you now Okay, not always. Look at the three examples. Three examples that obviously is partial delete. Highlight this. X minus 3, X minus 4, X squared. Suppose less than 0. Suppose, no, greater than. Okay, greater than again. Doesn't matter. It's not important. You see, wow. The professor explained me that when the exponent is even, you delete, I don't know if it's partial delete or totally delete. It's obviously partial because we have no equal sign. No equal sign, partial delete. I suppose que this inequality is equivalent to write x minus 3 greater than 0 and x not 4. Similar to this. What is the only difference? When you solve this inequality, x greater than 3, this inequality represents the interval from bracket or parentheses, 3 comma infinity, and 4 as a whole. So our representation graphically look like that. Let me try to do my best. Okay, this is 0, this is 1, this is 2, this is 3, this is 4, right? So now the interval is from 3 to infinity, but in the middle of the process we have a hole, the famous hole that we have totally outside. That is the reason I do not consider it. Now I consider it. So what is the answer, Professor? Well, the answer is parenthesis 3,4 union 4, infinity. Do you see that? Okay, there's no big deal. You need to get the mechanical of this. The mechanical, you have different factors. Like after you factorization the polynomial, you see some factor que is raised to the even exponent. You delete partial or delete total depending of the sign of the inequality. Is equal or not equal. And you converting the inequality and compound inequality, and you solving graphically. Exactly the same we are doing in intermediate algebra. But we have another scenario. Guys, do you follow me or no? No? Yes? Say something. Confusion? Yes. Yamin de la Paz? Rebecca is okay? Benjamin? Cool, you are the best in Miami-Dade College, I told you. It's easy, we are good teams. Okay. Let me try one more. We are a scenario. Suppose this, x squared plus 4, x minus 5, less than 0. I changed something. I changed a little bit the format for this factor. Okay, normally you write like that, x plus 4 squared maybe. In this case, no, I put a square inside. And it's important, extremely important to understand the difference between this guy and this guy. In both is quadratic functions. And the first guy, let me try to do my best. And the first guy is a parabola, of course, but this parabola passing through, open up, and the vertex is a negative. That is the reason that the parabola is always positive from 0 to infinity, but it's not only positive in -4, because actually in -4 the parabola touches the x-axis, therefore it's 0. That is the reason that you included the restriction. However, this parabola is different. This parabola is, look, the vertex lie in the y-axis, is in 4, it's pointing at the point 0,4, no? And it's pointing the point was -4,0, so on the x-axis, the y-axis I suppose that here. You see the parabola open in that direction. Wow! And see this parabola open in that direction, this parabola is always positive. And the positive, when it's positive 100%, I can delete totally. So in this case, no equal, but this kind of factor is total, and this is equivalent to say x minus 5 less than 0, x less than 5, and the answer in interval notation is from negative infinity, comma 5 parentheses. Cool? So we have different scenarios, special. Let me try to summarize. When you have factors, okay, good. Look, suppose we have the collection of the factors. And you put it here greater than 0. And you have the factor x minus 3. You have the factor x minus 5 squared. And you have the factor x minus 4 squared. And you have the factor x squared plus 1. Okay, by the way, guys, this is like an irreducible quadratic, you know? Okay, you know that the solution of this is complex. You know? Are you familiar with this, right? So you can simplification this inequality like that. You take x minus 3 greater than 0, and you totally delete this guy. And you, this and this, partial delete. And how you indicate partial delete? You express it like an and conjunction, no 5. And conjunction, no 5. Okay, therefore the solution is, in my opinion, when you solve this, you know, this is easy, it's linear. Entonces, this is my original line. Infinity positive, infinity negative. I suppose que sirve here. 1, 2, 3, 4, 5. We start from 3 to infinity. That part is from 3 to infinity. So basically is from 3 to infinity, but we have to hold. Where? In 4 and 5. And the rest is okay. Parentheses, no bracket, no, because no equal. That part is okay, that part is okay, that part is okay forever. So my famous final answer in interval notation is parenthesis 3, 4, parenthesis union, 4, 5, union, 5, infinity, and that's it. 3 interval. This is this, and this is that. Super clear or super confused? Huh? I recall, guys, this is the advanced mathematics. It's not calculus, it's the pre-calculus. Calculus harder than this. But it's the foundation to understand. Any question? Any question? You follow me or no? Come on, doing the homework online is the only way that you have to study. Any question that you have doing the homework online, you communicate with me. Email me, send me a screenshot. I solving your problem in 5 seconds. I send to back the solution. And this is this in my mind is the way that I try to planning to study this. Okay.
So professor. So for this one, we don't have to select random points to test.
Say again.
For this example, we don't have to select random points to test.
No, good question. Good question. No, because using this special I simplification, my horrible inequality contains 4 factors and only 1 and 2 restrictions. When you have 2 factors or 3 factors, definitely you need to do it that way, mister. Yes, you're right. Good question. I like this question. Let me try now to do one example of the rational. Rational, remember, it's the same idea. But in this case, a little bit more complicated because we have 2 polynomials, no? Polynomial at the top and polynomial at the bottom. Suppose this example. Example number 1, rational, easy. X plus 2 minus 2 divided by x minus 1 and x plus 1. I put it artificially no, mandatory, write it down or equal to 0. That suppose it's given this inequality. I need to solve it. Okay, nice. Okay, two things I save time. First of all, right hand side is 0. Not always. You see another example before, after that. Okay, no 0. Secondly, okay, somebody know me, do the factorization of this polynomial and factorization of this polynomial. So actually, it's expressed in factorization. Nice. I appreciate so much that favor. Oh no. Sorry. I appreciate so much that favor. Now I find the critical value, CB. I take the polynomial in the top, equals 0. That means x equals 0 and x equals 2. I take the polynomial at the bottom, equals 0 separately, independent. Is x equals 1 and x equals -1. Entonces we have 4 critical values. 1, 2, 3, 4. Okay, no factor with the even exponent, no delete, no partial delete. This is a classical example. Okay, it's not special. Now make a partition. All real number line famous. Okay. How many testing? I need to declare it. No idea. Let me see. 0 is the critical value. 1 is another critical value. -1 is another critical value. And +2 is another critical value. Therefore, we have 4 partitions. We have 5 intervals. I pick one arbitrary testing point. And -2 or -3 or -4 is the same behavior. And -half maybe. And between 0 and -1. And +1/2 is another testing point. And 1.5, 3/2, and 3, 4 or 5. This is, and red color is my testing point. Okay, after that, you can plug it in one by one into the original equation. It's a one way. I don't like personally, but it's okay. I recommend to my students doing in the table format. I listing the testing point. Okay, we have 5. No? Total is 2, -2, -2, -1/2, +1/2, 3/2 or 1.5, either way, in fractional decimal, and 3. And you list in the factor of the expression. Actually, we have 4 factors. The factors are x. Doesn't matter the order. The order is not important. The order is not important. X -2 is the second. X -1 is the third. X plus 1 is the last one. And you attach 1 extra column in which you condensing all information about the sign. It's called total. I call it. Okay, so now plug it in. This is the long way, but it's easy. It's just plugging in. It's negative. You correct me if I make a mistake. Negative. Entonces in total we have positive because we have many negative. 1, 2, 3, 4. It's obvious it's even. Entonces positive. And the second, que es -1/2, is negative. And the last one is positive. 3 negative is negative. And the +1/2, we have positive, negative, and positive. Okay, it's positive. So we have only 2 even number. And 3/2 is positive, negative, positive. Oh, you have only 1 negative. This is negative. And 3 is everything is positive. Not always happen, but frequently happen that the last row is positive, positive, positive. Okay, entonces, I suppose que everyone understand where I come from this sign, yes or no? You want, I can explain, but only one, no? Now, I come back to the original problem. The original problem sake is greater than, we investigate the positive guy. And the positive guy is true here. Here and here. 3 intervals. So we have 5 intervals, 3 intervals. The testing point was true. Good, I lie. And 2 no. It's false. If you want, you put a false here. I don't lie. I don't care the false, because false means no solution. It's much better the true. You should indicate this. So let me try to do using the green color to highlight the true. The true is a -2. The true is a -2. Look at that. Okay, remember the interval is extending from the critical value. Remember, -2 was hypothetical. Guy gave pick arbitrary. Are you positive or negative? No, I am positive. Okay, you said you are true. Now, and half also. EM3 to infinity. It's obvious que in this example, you include, well, no, it's not too obvious. Look, in this case, it's greater than or equal. So now, when you see this, you understand that the endpoints belong to the solution. But no, this is the new thing, bring me rational. Okay, S equal sign, good, include the 0 of the top part. But you know, the 0 of the bottom part, never a solution because to be undefined. So you include 0 and 2 like a solution, but no 1 and -1. Keep in mind this. And -1 no, parenthesis, 0 yes, bracket, 1 no, parenthesis, and 2 yes, bracket. So my beautiful final answer is answer. From -infinity, comma, -1 parenthesis, union, bracket 0, comma 1, parenthesis, union, bracket 2, comma infinity. End the story. Any question? What part you don't understand very well? I need to know, guys. No? Everything clear? Okay, one more example. One more example. Okay. One more example. This is a little bit complicated because this is example 2. Because we need to manipulate a little bit, not too much. 1 over x minus 2 less than or equal 2 over 3x minus 9. Okay, suppose it's given like that. Bam! This is my inequality. I need to solve it. And the student and even tutor making mistake to believe that this behave like an equation and make cross multiplication. This is wrong. Because the inequality is picky, inequality is sophisticated. Remember, when you have inequality and you multiply by a negative number, the signs of the symbol of the inequality is reversed. Suppose you have inequality, 2x minus 2x greater than 4, and you divide by a -2 because I want to isolate the x. So 4 divided by -2 and -2, but now the fact that you divide by a negative number change, reverses this sign. And otherwise, do not happen when you divide it by a positive, stay the same. So now, if you try to apply cross multiplication here, what sign you put here? You put less than or greater than? No idea. I said this is wrong. Some people can try to explain using cross multiplication. This is wrong. This is not good. So instead, but I get the right answer. By coincidence, you get the right answer. Okay, what should I do? Oh no, as always. What are the steps 0 to start? Right hand side must be 0. Please don't forget that. You move 1 over x minus 2 minus 2 over 3x minus 9 less than or equal to 0. You follow me? This is important. Without this step, you cannot progress in the solution for the network. Okay? What is the next step? Well, I try now to condense in these two fractions. Okay, in this moment, they are separately in only one fraction. So only one compact fraction. Okay, for doing this job, first of all, I need to find the least common denominator. Least common denominator. But okay. First of all, before the least common denominator, I see that in this binomial, the great common factor is 3. You factor out 3x minus 3. Okay, ready. Be ready then. Now, the least common denominator in this case, not all, but in this case, is the collection of the factors 3, x minus 3, and x minus 3. And you copy only one denominator line, and the bottom you put 3, x minus 3, x minus 3. I copy exactly the same in the right hand side. Okay, now doing our best algebra, intermediate algebra, easy. You divide LCD, divide by LCD by denominator 1. Denominator 1. Who is denominator 1? Denominator 1 is x minus 2, right? This is denominator 1 in the first fraction. Of course, this is cancel and stay alive. 3, x minus 3. Of course, time 1 is invisible. Minus, do you follow me? LCD again. Okay, 3, x minus 3, x minus 2. Now divided by denominator 2. And denominator 2 is 3, x minus 3, no? So this is cancel. This is cancel. Stay alive, x minus 2. X minus 2 times minus 2. So 2 times x minus 2. Guys, everyone follow me in this elementary algebra? Sure? Yes or no? All right. Opinion. I don't see the chat. Let me try to see. Got. Okay, cool. Okay, let's continue then. Erase that part because everyone understands very well. Yes, Claudia. Okay, now in the top part. Clear. Shane is clear. Now the recipe is okay. You distribute the property and combine like term. 3x minus 9 minus 2x plus 4 over 3x minus 3 x minus 2 less than or equal to 0. Almost, I finish. Not yet, because I combine like term. 3 minus 2 is 1x. And negative 9 and positive 4 is negative 5. Over 3x minus 3 x minus 2. Wow, fantastic. Now, guys, I guarantee you that this inequality now is easy to analyze. Is equivalent 100% to the horrible inequality is given at the beginning and nobody understands. Okay, remember, I move everything to the left. I try to use my trivial algebra and condense it in only one rational function, like a fraction, division to polynomial, and that's it. Okay, okay, one more detailed, sophisticated. Pay attention, please. In this moment, when you have a constant, like a 3 or like a 5 or like a whatever, I can delete this. I can or no? Let me know. You understand that the solution of the inequality is totally irrelevant of these three. These three do not afford extra information. Do you understand, or you don't understand? 3 is positive. And you understand that the positive is similar idea to the thing we are doing before of the exponent, the factor with the exponent even is positive, you delete or partial, depending, no? Si touch the 0 or not. In this case, 3, no, 3 is always positive. So the positive no, do not apport information. Okay, do you understand this possible delete? Do you understand? Yes or no? I need to hear your opinion. Do you understand que I delete this 3 or not? A ver, José Cabrera, Mike Díaz, Benjamin Hart. Do you understand? This 3 is totally irrelevant, guys. And the equation is the inequality is different to equation. It's more flexible. Now everything is positive. Do not apport information because the sign stays the same. Greater than or less than. When it's equal, no, it's more accuracy. You know? Okay, now, but I suppose that when I manipulate, this is just hypothetical. When I manipulate, you have no 3, you have minus 3. I can delete. Yes or no? Opinion. Si es negative 3. Of course, it's not negative 3, it's positive 3. That is the reason that when it's positive 3, the answer, of course, is no. Yes, I can delete. So when it's positive 3, I can delete, yes. Pero si es negative 3, you can delete. No, I suppose que no. Because the professor explained that the negative is important and the positive is not important. That's why should I do suppose it's negative? And the hypothetical scenario is negative 3 or negative 4 or negative whatever. Well, I change the sign. You multiply by negative 1, suppose both sides. Entonces I affect these 3 become negative, no? Positive. And the rest stays the same because the hypothetical negative 1 can multiply here. I multiply negative 1 here and negative 1 here. And it's a 3 positive. And this, of course, changed. This is no x minus 5. Now would be 5 minus x. But this is not important. Okay, now, but when you multiply by negative 1 inequality, of course, this change. Like later down. In conclusion, si es negative, you can delete also. But the difference is that you reverse it this time. Okay? I suppose that you don't see any example of this, but just in case. You never know. Okay. Let's focus now in this new expression that are almost the hard part we are doing. No delete anything, no even exponent, no. Critical value in the top, F5. Critical value in the bottom is 3 and 2. We make partition. Infinity, negative, infinity. Partition R in 0, 1, 2, 3, 4, 5. And the testing point guys select was 1, maybe good. 2.5, maybe good. 4 and 6 or 7 or 11, whatever. I built my table. Remember, the first column is testing point. I listing. We have 1, We have 2.5. We have 4. We have 6. The factor in one problem are, I go, not to the original, I go to this expression that I enclosed in the box, x minus 5, it doesn't matter the order, x minus 3 also, x minus 2 and 2. Okay, evaluate now. Plugging in 1, plugging in 2.5, plugging in 4 in each factor and determine the sign is important for me. The value no important. Es minus, es minus, es minus. Entonces es minus. 3 minus es minus. Es minus, es plus, es minus, 2 es positive. 2 minus is positive. This is minus, this is plus, 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 plus. Is minus, only one minus. And plus, 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 everything plus, and the last one is plus. However, we come back at the beginning. Y ahí sí que our inequality in this example is less than or equal to 0. Es sinónimo to be negative. So the true guy is the negative. This is the true guy. And this is the true guy. The true guy was when the testing point was 1, so this interval, and 4, because this interval. The rest, 2.5 doesn't work, and 6 doesn't work. And what about the endpoint? Include the endpoint, yes or no? Well, the only endpoint that we include is 5. It's the 0 of the numerator, because it's equal. You include it. But the other no, because the 0 of the denominator going to be on the 5. And 2 parentheses, and 3 parentheses, and 5 brackets. So my beautiful final answer is answer. From negative infinity, comma 2, union, parentheses, 3, 5 bracket. 1 final answer. Do you understand very well or no? Cool. Okay. As I propose now, the rest of the time we have it's not too much. Let's do in the review, or at least start doing the review. Let me try. I bring the page of the review. Okay, guys, don't worry too much, because I have in YouTube one video, or no video. It's a list video. It's like several videos que somehow solving this review completely. So let's try to do our best in between today and Wednesday. Now, see, we don't finish, no problem, because I have in YouTube one video that I want to send the link. I want to send, when the class is over, the link of this video plus another video for the solution for the review. Question 1 is from the polynomial listing each real 0 and its multiplicity. Determine whether the graph crosses or touches the x-axis and the x-intercept. Okay, easy. The function is f of x equal 1/3 x to the 4th power x squared minus 5. Let me try to use another. Okay, look. I copy the expression. Do you see very well my whiteboard?
Yes.
Okay, cool. Now remember to find the x-intercept, you enforcing the function equal to 0, 1/3, I don't care, x to the 4th power equals 0. You take each factor one by one, and another is x squared minus 5 equals 0. Okay, this is a equation of the 4th degree. We have 4 solutions. pero any solution is 0, so you can condense x equals 0, multiplicity 4. M indicate repetition. So actually, so you list the 0, yes, Jose, thank you, Jose. Yeah, 0, 0, 0, 0, but not necessarily to write like that. So it's 0 multiplicity 4, because it's repeated 4. In the second part, we have x squared is a quadratic equation, equal 5, apply square root both sides, x is equal plus or minus radical 5. And so it's radical 5 positive and radical 5 negative. In total, 1, 2, 3, 4, 5, and 6. Because the degree of this polynomial is obvious, que es 6. Remember the end behavior expression is 1/3 x to the 4 x to the second, because I consider it negligible that 5. That 5 is nothing, $5. And in end behavior is infinity. So now you put together is 1/3 x to the 6 power. So the degree of the our polynomial is 6. This is totally out of the question, no? But it's okay. And now you need to indicate si touch or cross the axis. Remember, if the multiplicity is even, so in my opinion, the graph of this polynomial by hand, not necessarily decimal now, and no question, but I want to discuss it because I want to clarify this idea. Look, the end behavior, I suppose, is degree 5 and coefficient is positive, look like that. Yes or no? This is the end behavior representation. So right up, left up. But we have 0 and 0. And we have 0 and radical 5, is 2 point something positive. And here again minus radical 5. Our graph of the polynomial, in my opinion, look like that. Cross it, touch it, and cross it. Of course, guys, I am doing a mess. This actually is not like that. Because remember, the graph of the any polynomial is a smooth curve. Smooth indicate also case like that. Cross it. Let me try to use another. Yeah. Cross it. Smooth touch and a smooth cross. This is obvious, in my opinion, que 0 multiplicity 4 touch. Este option B, no? Hay que subir. Remember, the test is no multiple choice. The review, yes. To show you easy way to understand the problem. Everyone understand very well the question 1 in the review? Sure?
Yes, sir. Yes, sir.
Yes, sir. Okay, cool. Say again?
Is there also an answer sheet attached to you so you know if you know it correct?
Sorry, I don't understand very well. Your microphone is interrupted. Say again, please. It's important for me to understand your question.
I wanted to ask, is there an answer sheet review so you know if we're correct or not with our answers?
Sorry, I don't understand. The microphone is like intermittent. Could you repeat again one more time? Slowly. Slow down.
I wanted to ask if there will be an answer sheet attached to the review so that
No.
If our answer is correct?
No. The answer is no. Review is for doing review, but no point for this. You don't need to bring me anything. Okay, guys, we continue. Number 2 question. Number 2 question is similar, very similar to question. Repetition again, but in this case, the function is polynomial again. Is 1/2 x to the 4 power x squared -5 x -2. Wow. I suppose that the degree of this polynomial is 7. Yes or no?
Yes.
Yes. Okay, then to make 0, one solution is x equals 0 multiplicity 4, similar to another problem. Another solution, that is the solution for that part, was similar, was plus radical 5 and minus radical 5. It's a quadratic equation, no? Multiplicity 1, of course. Multiplicity 1, of course. And the last one is x equals positive 2, multiplicity 1. And remember, multiplicity 1, cross. Cross, cross. And multiplicity even, touch. Entonces en 0, multiplicity 4. I suppose que I don't know si es option C o D. Es C, ¿no? Es C. Sí, es C. Es C. I guess so. I am bad in the selection. Cool. No problema, guys. You understand very well or no? Oh. What the hell is that? Clear is the change is clear. Okay. Let me try to bring the Desmos. Could you open the Desmos and the link I sent last time? Or no? Yes or no? Could you open? Or no? Or we have no time. Okay, Jose Cabrera. Let me try to find review. Let me see if it's review 4, review 4, review 2, review 2, review 1. Oh, there you go. No, coño. Oh. Sorry. MAC1140 review for the test 4, 2, 1. There you go. Okay, cool. So now let's move on to the question 3. And the question 3 is, do the graph of the one rational function. So we have 1, 2, 3 examples. Yeah, 3 examples of the graphic of the rational function. Let's do it. It's given in the weird way. Let me show you. Look, question 3c. Graph the function. The function is f of x equal x minus 1 over x. I don't understand very well, but okay. I propose you put in the common denominator, no? Because the definition of the rational is division to polynomial. No? So I copy x like LCD, and you have x squared minus. Cool. So I saw okay, we have polynomial degree 2 at the top and polynomial degree 1 at the bottom. And factory form is easier, in my opinion, is the difference of a square. You factorization xx11 plus minus and x. Okay, cool. This is the factory form. Okay. And remember the 7 famous steps to do any graph is step number 1, factory 4. In this case, we cannot delete anything, no cancel out, no whole thing. After the y and z, que se evalúa en 0. Bueno, this is weird because 0 in the denominator to be undefined. I predict in 0 we have vertical asymptote. I predict. And this is undefined because it's positive infinity or minus infinity. We don't know clearly. The extended set is easier because it's when the polynomial at the top is 0, that polynomial now in the top is 0. And two different ways to see that. You can see in this way or in this way. It's obvious que es en positive 1, negative 1. So it's x equal 1, the 0, the top part, and negative 1. So actually, when I finish to do this, we have two extended sets at the point 1,0 and the point negative 1,0. Okay, nice. What about vertical asymptote? Vertical asymptote, remember, what is the formula? The formula is Q. And who's Q? The polynomial at the bottom, que es x. X equals 0. Okay, entonces I understand now in 0 is undefined because it's a vertical asymptote. Horizontal asymptote or slant asymptote. This is the complicated part. Remember the degree analysis. Degree analysis. If the degree, in our example, the degree is 2 and the degree is 1. Therefore, the degree of the top is 1 more than the degree of the denominator. To say we have a slant. Slant asymptote. Okay, by the way, it's easy because actually at the beginning, it give me somebody do, I don't know why, the long division or synthetic division. So basically my function is giving at the beginning, like a x minus 1 over x. And this is a slant asymptote. Normally, no. Normally, you need to asymptote. You need to perform division, no? Long division or synthetic division, either way you prefer. Okay, one more thing, important. Okay, symmetry. Symmetry is you replace x for negative x. And let's see what happened. This is minus x plus 1 over x because I changed the sign of this and the sign of this. And when you compare this and that, this is positive, this is positive, you see it's odd function because it's completely opposite sign, odd function. And the rest is, guys, you put in decimals and end the story. I want to show you my decimals. Look at that. No. Hello. Stop sharing. Switching the screen. Cancel. Okay, let me try to open decimals. Hello, decimal over there. No, not this one. Another decimals. Wait. Here. There you go. Let me share. Okay, let me minimize. And that one, click here. Click select the Skype. Switching to decimals. Bang, and bang. Do you see my decimals? Okay, in my decimal I have yes or no. Do you see or no? Guy, is the last guy. No, not yet.
I see the decimals.
Okay, waiting some seconds. I can see. Okay, it's a question 3. Look, I copy here. I copy different points, and this is the graphic. Wow, look at that. I saw this graphic is the blue color have two asymptotes. One slant asymptote x equal 1, y equal x, sorry, and one vertical is x equals 0. Is exactly on the y-axis. And the typical point 1,0 and negative 1,0 is the x in a set. We have no y in a set. I select 4 points arbitrary. No, arbitrary. It's an odd function. It's symmetric. I select, for example, 2,1.5. I suppose we have negative 2, negative 1.5. The same value but opposite sign. It's a typical odd function. 0.5 positive is negative 1.5. And other hands and the symmetry part is negative 0.5, 1.5. Okay, guys, time is over. We finish. So now, when the class is over, I will send this video plus another video with the solution of the review. And we continue Wednesday. Okay? And see, we finish, you know, you study by yourself. Okay? Cool? Cool?
Thank you, Professor.
My pleasure, anytime.